Alright guys, today we're going to be talking about graphing radical functions, and before we get into it, why don't we go ahead and first talk a little bit about radical functions. So if we look at the parent function of a radical function, we'll have the following. We'll have y equals the square root of x. So that would be considered our parent graph or our parent function. Okay. Now if we compare this to the parent function of the quadratic, we have the following. Y equals x squared. So this is the parent of a radical, this is the parent of a quadratic. Okay? So let's take a look at what happens here when I take the inverse of my parent function of the quadratic. So in order to do that, I need to replace the x with y and the y with x. So I'll have the following: x equals y squared. And I'm simply just going to take the square root on both sides now. Right? I'm going to solve for y. So y will equal the square root of x. Well, look what happens here. When we take the inverse of our quadratic parent function, it returns us the parent function of our radical, right? So of our radical parent function. Now, let's take a look at what changes here. So we know that with our parent function of our quadratic, our domain will be all real numbers, right? Because we have a graph like this, right? And it's going to be all real numbers. We're talking about the x. The range here, so the range will be all numbers. So y has to be greater than or equal to 0, right? So y has to be greater than or equal to 0, right? Here's our graph. So our range would have to be y is greater than or equal to 0. Now, look what happens when we take the inverse. Okay? Look what happens to our domain. Can we plug a negative into this? Right? Mathematically, that doesn't make sense because then it would be imaginary, right? So our domain here, we have restriction on it. So when we take the inverse here of our radical, of our quadratic, and we return our radical, we'll get the following for our domain. Okay? Our domain here is going to have to be, x has to be greater than or equal to 0. Okay? Our range, however, will stay the same. So y has to be greater than or equal to 0. So we can see that when we take the inverse of our quadratic parent function, right, we run into an issue where we need to restrict the domain. That's what we have here. So just keep that in mind. We move forward. So let's get into an example of graphing these by hand. Alright guys, so moving on, again we have our radical function here. And I went ahead and wrote down the domain and range that we will have for this particular radical function, right? So the domain is going to be, x has to be greater than or equal to 0, and our range has to be greater than or equal to 0, okay? So you can do this a few ways when you're doing it by hand. You can create a table of values, or you can just make a list. In this case, I'm just going to make a list. It's a little bit easier in this case. So let's go ahead and do that now. What we want to do here is we want to pick values that are going to satisfy our domain, meaning I can't pick a value that's going to be negative and plug it in for x, right? Because our domain has to be greater than or equal to 0. So I want to pick easy numbers that will satisfy this domain, okay? So I'm going to start with 0 because that's fairly easy. So I'm going to plug in a 0 in for x. And what will I return on the y when that happens? Well, the square root of 0 is just going to be 0, right? So we have the following coordinates here, which will be 0, 0. Okay, so let's keep going. Let's take the square root of 1. That's an easy number to work with, so the square root of 1. Well, the square root of 1 will be plus or minus 1. Now, careful here, we're only going to pick one of them because look at our range here. Our range is telling us it has to be greater than or equal to 0. So if I have plus or minus 1, I'm going to pick the positive one. That way it satisfies the range, right? So I'll have just positive 1 here. Even though when we take the square root of 1, we know it's plus or minus. Okay, but in this case, in order to satisfy the range, we need to pick positive. Alright, so we'll have the following. We plug in a 1, and we return to 1. Okay, let's start with our next one. Let's pick 4. So the square root of 4, again, is going to be plus or minus 2, but we know we are only going to pick the positive one here. Again, we just went over that. Okay, so we'll have, we plugged in a 4. And we returned a 2. Okay, and let's go ahead and pick 9 now. So let's pick 9, square root of 9. Again, plus or minus 3, but we're going to pick the positive. So we plug in a 9, and we 3. And this is sufficient to go ahead and graph now. You can keep going if you'd like, but 4 points, that's sufficient. So let's go ahead and graph them. So we're going to go to 0, 0. So I'll make a point at 0, 0. Then we're going to go over 1. So over 1, up 1. So we have right there. We're going to go over 4. So 1, 2, 3, 4. And we're going to go up 2. And we're going to go over 9 and up 3. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then we're going to go up 3. Start up here. And we're going to go ahead and make a point. Alright, at this point we can go ahead, and this needs to come up just a little bit. We can go ahead and connect these. So let's go ahead and do that. That's it. Okay, so there is our graph of our radical function. So those are the steps you need to go through when graphing radical functions. All right guys, so here is our next example. So we're dealing with a cubed root now, not a square root. All right, so it's a little bit different than last problem. And recall what we did in the last example, right? We determined what the domain and range was going to be of that function before we even graphed it. Well, we're going to do the same thing here. So remember what you did in order to do that, right? We looked at the parent graph of a quadratic, or x squared, right? So for example, we looked at the parent graph of x squared. So we had y equals x squared, and we know that we have a graph that looks something like this, right? We know this. And from this we were able to determine, well, the parent graph of a quadratic, the domain is going to be all real numbers, okay? And the range is going to be all numbers greater than or equal to 0. Okay? And from that we took the inverse, and when we took the inverse, right, we got y equals the square root of x, and this is what we were graphing, right? So again, this would be considered the parent function of a square root, and that is what we were graphing. And we were able to determine, okay, well, are these domain and range going to change for our square root value now, right? Well, we would determine that the range is going to stay the same, right? The range will stay the same. However, the domain is now going to be restricted because, think about it, we can't plug a negative in here because mathematically that will be incorrect. It will be imaginary, right? You can't have a negative in here. It's impossible because we'll have an imaginary number. So the domain gets a restriction on it. It's no longer all real numbers. It's now, the domain is all numbers greater than or equal to 0. Okay? So what we want to do here, okay, is see, okay, if we can do something similar with this problem. Right? Let's determine what the domain and range is going to be before we even graph it. That way we have a better idea of what's going on here. Okay? So we're going to do the same thing here. So notice what happened when I took the inverse of x squared, right? I got the square root of x, right? Well, what happens if I do this now, right? What's going to be the parent function of a cubic? Well, that's going to be x cubed, right? And what do you think is going to happen if I take the inverse of this? Well, let's do it. We replace the y with x, and replace the x with y, and then we simply solve for y here. So we take the cube root on both sides, right? So we get y equals the cubed root of x. Now this is going to be considered the parent function of a cubed root. Okay, so what I want to know is, what is going to be the domain and range for a cubed root, right? What is that going to be? Well, again, looking back at what we had here, x cubed, what does that graph look like? Well, it looks something like this, right? And from this graph, we're able to determine, right, the domain and range. So it's a little bit different than x squared because the domain here is going to be all real numbers, and the range is also going to be all real numbers. Okay? Does that change though when we take the inverse? Okay, well, let's think about it. Plug in some values in for x and see what happens. So I'm going to go from both ends of the spectrum. I'm going to go all the way negative, and then I'm going to go positive and see what happens. So let's just pick easy numbers here. What happens when I plug in negative 8? So when x is negative 8, okay, what do I get for y? Okay, well, y is going to equal negative 2 here, right? Checks out. Let's do the opposite. What happens when x is going to be positive? positive 8. Well, y here will equal 2. It also checks out. So what this is telling me, right, as I continue to decrease the x values, I will continue to approach negative infinity on the function. Okay? And as I increase the x values, right, I will continue to approach positive infinity on the function. So what this tells me is the domain is going to be all real numbers, right? And my range is also going to be all real numbers. It stays the same. Okay? So for this, when we graph a cubed root, we can expect the domain to be all real numbers, and we can expect the range to be all real numbers as well. Now, you don't have to go ahead and go through all of this, but this gives you a clear picture of what you're graphing. That way you can make sure that you didn't make mistakes at the end, right? So if this all checks out, you know that you did it right? So our domain and range we can expect to be all real numbers here. All right? Okay. Let's go ahead then and start graphing. Now at this point you can make a table of values if you wish. For the sake of this video, right, I want to try to keep it fairly short. I'm just going to go ahead and plug in some values and we'll get the points that way. Right, so let's start at negative 12. So I'm going to plug in negative 12 in the x and see what I get for my y. Right, we know that this is really y, so I'm going to write it as such. So y equals 4 times the cube root of, and I said I'm going to plug in a negative 12, so I plug in negative 12 plus 4. Well, what happens here? Negative 12 plus 4 is going to be negative 8, right? And the cube root of negative 8 is going to be, well, negative 2. And then negative 2 times 4 is going to be negative 8. So what happened here? Well, I plugged in a negative 12 and I returned a negative 8, right? That's going to be a point. Okay, let's keep going. Let's do, let's pick negative 5. So we'll have y equals 4 times the cube root of, we said negative 5 plus 4. Now again, you could pick any value you want for x. I'm just trying to keep this clean, okay? I don't want to deal with fractions right now, okay? So negative 5 plus 4 will be negative 1, right? The cube root of negative 1, well, that will be negative 1, right? And then negative 1 times 4 is going to be negative 4. So what happened here? I plugged in a negative 5 and I returned a negative 4. Right? There's another point. Okay, let's keep going. So let's choose negative 4. Alright, so going on to negative 4. So again, I'm going to plug in a negative 4 and plus 4. Well, what happens here? This all becomes 0, so the cube root of 0 is just going to be 0. Right? And then 0 times 4, well, that's just 0. So what happened? I plugged in a negative 4 and I returned a 0. Okay, let's go ahead and put these points on and then we'll continue on and that will be it. All right, so we have negative 12, negative 8, so we're going to go over negative 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Right, extend it a little bit. And then we're going to go down negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. So we have a point right about here. Okay. Alright. Our next one, negative 5, negative 4. So we're going to go over negative 5. So 1, 2, 3, 4, 5. And then we're going to go down 4. So 1, 2, 3, 4. Alright, it's fairly difficult without any labels here. So 1, 2, 3, 4, 5, and then down right about here. Again, so we went over negative 5 and down 4. Okay. Right here, we're going to go over negative 4. So 1, 2, 3, 4, right here. Point. My marker's dying. Okay. All right. Let's go ahead and finish this guy off. So I'm going to erase this work here. So go ahead and erase this work and we will finish it off. Alright, so the last value that we plugged in here was negative 4. So let's go ahead and plug in a negative 3 and see what happens. So we get y equals 4 times the cube root of. We said we're going to plug in a negative 3. Okay, so negative 3 plus 4 is going to be 1. Cube root of 1 is just 1. And then 1 times 4 is 4. So we plugged in a negative 3 and returned a 4. All right, let's do one more point. Let's go ahead and plug in a 4, right? So 4, and then the cube root. 4 plus 4, right? So 4 plus 4 is 8. Cube root of 8 is going to be 2. 2 times 4 is 8. So 4, and we get an 8, right? Okay, let's finish this guy off. So let's go ahead and make these last points. So negative 3, then up 4. So we're going over negative 3 right here, then up 1, 4, okay? And then we want to go ahead and do over 4, right, over 4, then up 8. So 1, 2, 3, 4, then we want to go up 8. 1, 2, 3, 4, so that's going to be 8. And that puts us right about here. Okay, so at this point, all we have to do is go ahead and connect our points, and our graph will be done. So here we go. And here is our graph, right? And we can see it makes sense, right? We said our domain is going to be all real numbers, right? So let's go ahead and write that down. We said our domain is going to be all real numbers, and we said our range is also going to be all real numbers. And looking at this graph, that is correct, right? All right, so it's always a good practice to go ahead and determine what your domain and range is going to be before you go ahead and graph. Right? And that is how you go about graphing radical functions.